Hello, and welcome to our second podcast. I had a request to do this one in a British accent. However, since I have no idea how to do a British accent, I'm going to decline that request. So sorry, Maple Leaf, it's not going to happen today. So today we're going to talk about coenzyme Q and why you probably don't need to supplement with coenzyme Q. First off, let's look at some of the claims by a popular supplement manufacturer. I'm not going to identify the manufacturer because I don't want to promote their business. But you see very general claims with a lot of supplement. These are claims that have no scientific backing and really in the scientific community have no meaning. There's no meaning to saying boost immune system or improves brain function. These are things that we cannot measure, cannot assess. And so they are put there simply for the people who are going to be purchasing these supplements to draw them in. So what is coenzyme Q? So the first part of coenzyme Q is this part of the molecule. This is called a quinone. And that is what coenzyme Q is. It is a quinone derivative. This is a small organic molecule that has a complex network of pi electrons. And if you took organic chemistry, you know what that means. If you didn't take organic chemistry, basically what it means is this is a type of compound that can exist in multiple oxidation states. And in the case of coenzyme Q, there's 3 potential stable oxidation states that it can exist in. And this allows it to perform its major function in the body, which is to shuttle electrons in the electron transport chain. So what is the electron transport chain? The electron transport chain is a piece of the puzzle for mitochondria to make ATP. And so the one claim that coenzyme Q assists in making energy in the cell, this is somewhat true because this is a crucial part of generating the means for mitochondria to make ATP. The other part of the molecule that we want to take stock of is this over here. This is an isoprene group, and we have an N number of isoprene repeating units in coenzyme Q. In most living organisms, that N equals 10, which is why we have CoQ10 rather than some other number. This is going to be something important to remember because it plays both into the function and tells us a little bit about who could benefit from supplementation. So what does coenzyme Q actually do? Well, when we look at our mitochondrial inner membrane, we have complexes that are proteins that generate a proton gradient. What this really does is this is part of the complex of proteins that are going to allow mitochondria to generate ATP. And in order for this to occur, we need to be able to shuttle electrons from one complex to the next. And that's the job of coenzyme Q. So this is the best I could come up with ChemDraw. But this is a pictorial representation of coenzyme Q. We have the big quinone portion and a long hydrophobic tail. That's the isoprene compound part. What that hydrophobic tail does is it allows coenzyme Q to stay in the membrane in association with both of these complexes. So it can pick up electrons from one complex and deliver them to the other. And that's the real function of coenzyme Q in energy metabolism. The ability to change these electrons or shuttle these electrons from one complex to the other is going to allow the mitochondria to make ATP at some point. So where do we get coenzyme Q? Well, first off, coenzyme Q is going to be found in any animal that we eat. So if you eat animals of any sort, they use coenzyme Q for the same things. And so all of their cells are going to have a large amount of coenzyme Q as well, especially those that have mitochondria in them. So if you're eating meat, you're getting enough coenzyme Q from that. Good news is we also get them from plants because it turns out that every living organism on Earth uses coenzyme Q. In fact, the colloquial name among biochemists for coenzyme Q is ubiquinone because it is ubiquitous in nature. We can find it in virtually everything. As long as you're eating things that are whole foods or have whole cells in them, you're going to be getting coenzyme Q from your diet. So what about refined foods, things like sugars or refined flours? Well, unfortunately, because most of the components of the cells are removed during the refinement process, you're not going to get CoQ from them unless it's supplemented. Also, we actually make quite a bit of coenzyme Q in our liver. So this is something that you often hear coenzyme Q as being vitamin-like. it's not really vitamin-like because unlike vitamins, we do not need to get it from our diet. We can manufacture enough of it in our own biosynthesis in liver metabolism. So how does the liver do this? Because this is important in terms of who might benefit from supplementation, because there are some subsets of the population that would benefit. So the biosynthesis of coenzyme Q starts with a compound called acetyl-CoA. Acetyl-CoA is often called the crossroads of metabolism because so many things pass through this through both synthesis or breakdown in our metabolic pathways. We get acetyl-CoA from the metabolism and the breakdown of all of our energy metabolites. So whether it's carbohydrate, amino acid, or fatty acids, we can metabolize these into acetyl-CoA. Now, if you took general biochemistry in college or even in high school, you'll know that acetyl-CoA goes into the citric acid cycle, and we're able to use that to manufacture ATP and energy for the cell. But acetyl-CoA is also a synthetic starting material for a lot of things, including a variety of lipid synthesis pathways. So fatty acids are one thing that we can make from acetyl-CoA. But one of the parts we want to pay attention to is the production of a material called hydroxymethylglutaryl-CoA, or HMG-CoA. HMG-CoA makes a compound called mevalonate. And this is important because mevalonate, this reaction is the control reaction of cholesterol metabolism, because we utilize this pathway to control cholesterol synthesis with people who have hypercholesterolemia, because that's what our statin drugs do. They block the enzyme that convert HMG-CoA into mevalonate, and therefore we're less likely to make cholesterol in our liver. The problem is, if you're on a statin drug, this reaction is also the controlling reaction to the synthesis of other isoprenoid compounds, including coenzyme A. So if you are on a statin drug, you're going to be less likely to be making enough coenzyme A through natural biosynthesis. So who could benefit from a CoA supplement? Really, the major group of people who could benefit are people who are elderly for a couple of reasons. Our biosynthesis decreases with age. We're more likely to have some level of liver failure as we get older, and older individuals tend to have a reduced dietary intake as well. In addition, individuals who are on statin drugs to control cholesterol are going to be getting less biosynthesis. And as a physician, when you think of somebody who's on a statin drug, often they are on a statin because they are overweight and have hyperlipidemia and hypercholesterolemia. And so these are people who are also going to be on restricted diets because we're trying to lower cholesterol levels, lower triglyceride levels. And so their dietary intake is going to be lessened as well. So there is a subset of the population who is going to benefit from coenzyme Q. If you are young with no liver issues and have a healthy diet, coenzyme Q supplementation is not going to do anything for you because your biosynthesis is going to match what you need, your dietary intake is going to supplement it as well, and you're less likely to have any type of deficiency in coenzyme Q, so it's not going to be a beneficial supplement for you. Anyway, that's the podcast. I hope you enjoyed it. I hope you learned a little bit about coenzyme Q. Have a good